So here's another project I'm working on. I want to make a laser cut clock, mechanical clock. So I've got here the first rev. I've started putting numbers on every part of a set that I laser cut, so I can track what goes with what, because for the laser cut crossbow project it started all getting a bit skew-iff halfway through. So a person by the name of rlogin Unix on the Berkeley forums has put up a series of posts that go really deep into like clock design, and one of the things they put up was an OpenSCAD file that had this design in it. So I tweaked it a little bit, not too much, but this is the thingo that the core of a clock. This is the thing that does the ticking. So this escapement wheel here has some torque applied to it by maybe a weight or a spring or something that tries to turn it this way. And then this is the escapement fork, I think, is the term they use. Yep, and it has the pendulum attached to it. And so there's no pendulum and no spring here, so I'm just going to use my fingies. But the general gist of it is you try to twist this, and then the pendulum makes this wobble back and forth. And because a pendulum of a set length ticks at it oscillates between extremes at a set rate, you can use this mechanism to measure time. Quite inaccurately, really, but it's cool to watch it spin around and do its thing. This was the first rev. I made it just to sort of get a feel for the mechanics of things and how things, what sort of size I'd need to make it, and so on and so forth. But I've got version 2 over here. So it's more or less the same thing. It's got the escapement wheel here, and it's also got like a spool on it with some string hanging down from it, and that's giving it the torque. And then over here there's a piece that is attached to a steel rod with some weight on the end to make the ticker-tocker business happen. So if I chuck some weight on that string, just a clamp, it starts ticking. So I had to go through and touch up all the teeth a little bit. This will probably stop ticking shortly because it's really quite inefficient. You can hear that sort of crunchy grinding sound of the teeth sliding over each other. So that's the sound of energy going to waste, which is bad. So right now this will tick until that hits the ground, and that will probably happen in about 2 or 3 minutes. Whereas, you know, a proper clock, it would run for, you know, a day. Once you wind it up, I've seen ones that have like a ratchet mechanism, and you pull the counter side of the string and it lifts the bob up. So, you know, as a proof of concept, it does what it's meant to do. It doesn't really tick very consistently sometimes. I think you can see there's a bit of wobble happening there. There's not a rigid coupling between the pendulum arm and the pendulum itself. Hey, it's gone crazy. So there's some cool geometry happening here. So you see, as the tooth of the escapement wheel scrapes up this little ramp here, that's what gives the pendulum the kick to the left. So it kicks up. And then on this side, when the pendulum swings back down again, you see the tooth scrapes across that angle here along my thumbnail, and that's what gives it the kick in the other direction. So that's what motivates the pendulum to swing back and forth. I think that's pretty cool. So yeah, I'm reasonably happy with this. So in order to make this into a clock, you need to have some 1:60 ratio between the escapement, or in this particular case it does 1 revolution a minute. That's not necessarily the case, but so for this one I'd put a 1:60 gear ratio, probably with 2 different gears, 2 different sets of gears, to get that to minutes, and then another 1 to 12 to bring it to hours. I did look at trying to get all of the seconds, the minutes and the hours handle stacked up coaxially on the same axis, you know how a clock normally is. But that's really hard with only using laser cut parts. So I've got some bolts and bearings and such, but predominantly I want to try and keep it as laser cutted as possible. because I could turn up like concentric shafts on the lathe that pass the rotation through to the hands that you can just pop on the front. That'd be trivial, but it's not so easy to make those things out of laser cut wood. But as you can see, it's getting close to the floor now. This is actually the longest it's ticked run since I built it. So I guess the last touch-up I did, sanding the teeth, helped it out. That was pretty cool. Okay, that's all. Bye-bye.